Hi, I'm Mina.
And I'm Yules.
Thanks for tuning in to Artificially Informed.
TTS, the Deep Dive episode 2026-04-24.
Imagine living in this beautiful, sprawling old house for decades,
Yeah.
every creaky floorboard, every drafty window. And then one day you decide to renovate the cellar only to discover that your basement is actually a dormant nuclear reactor.
That is a terrifying thought.
It really is. But that is exactly what Europe just found out about the ground right beneath its feet. So welcome to another deep dive. Today is Friday, April 24, 2026, and we are unpacking the invisible architecture of our world.
We really are.
Yeah, our mission today for you, the listener, is to map out these massive unseen forces that are controlling literally everything around us, usually completely out of sight.
It's an unsettling analogy you made, but it's entirely accurate. Because whether we are looking at, geological monsters slumbering beneath our cities or geopolitical maneuvers happening in the shadows of global trade routes, the theme today is revelation.
Revelation, I like that.
Yeah, uncovering things that have always been there, dictating the terms of our reality while we just remain blissfully unaware.
Right, and it forces you to ask this question. If we missed a 3,000 square kilometer supervolcano in the middle of Europe until literally right now, what else are we completely missing?
It's a fair question to ask.
Because that is the first major revelation we really need to tackle here. Deep beneath the Bohemian Massif, which, for context, spans parts of the Czech Republic, Germany, Austria, and Poland, scientists just mapped a hidden supervolcano.
Massive one.
Yeah, and when I say supervolcano, I mean a complex network of magma deposits that's roughly the size of Yosemite National Park. And it's lurking beneath one of the most densely populated regions on Earth. How does something that massive just hide for so long?
Well, it hides because of the limitations of human perception, basically.
Mm-hmm.
We only just found it because of this massive leap in advanced seismic imaging.
Okay, so how does that actually work?
To really grasp how we missed it, you have to understand how we finally saw it.
Mm-hmm.
Geologists essentially performed a high-definition ultrasound on the Earth's crust.
An ultrasound?
Exactly. When an earthquake occurs anywhere on the globe, it sends out seismic waves. You have your primary waves, or P waves, which are compressional, sort of like a slinky being pushed back and forth.
Right.
And then you have secondary waves, or S waves, which move side to side.
And those waves don't just, travel on the surface, right? They punch straight through the center of the Earth.
They do, yeah.
Yeah.
And their velocities change fundamentally depending on the density, elasticity, and temperature of the rock they're passing through.
So they speed up or slow down.
Right. When seismic waves hit dense, solid, cold rock, they accelerate. But when S waves hit a region of the crust that is hot or slushy or partially molten like a massive hidden magma chamber, they slow down dramatically.
Why is that?
Because shear waves just cannot easily propagate through fluids. So by placing thousands of high-resolution seismometers all across Europe and measuring these tiny microsecond delays in how the waves arrive from distant earthquakes, supercomputers were able to map what we call a three-dimensional negative velocity anomaly.
A negative velocity anomaly. That's just the scientific way of saying the waves hit something hot and sticky.
Pretty much, yeah. It indicates a massive, deep-seated thermal anomaly beneath the Bohemian Massif, and this upends centuries of geological assumption.
Because that area was supposed to be safe.
Right, exactly. The Bohemian Massif has long been considered a highly stable ancient geological shield. Finding a sprawling magmatic system there forces a complete recalculation of continental risk.
Okay, I have to jump in here because my immediate reaction to hearing hidden European supervolcano is, sheer panic.
That's a natural reaction.
I mean, we are talking about an area packed with cities, infrastructure, millions of people. Are we looking at a Yellowstone situation where this thing could wake up and plunge the northern hemisphere into a volcanic winter?
Well, the scientific consensus in the current reports indicates that no eruption is imminent.
Oh, thank goodness.
Yeah, supervolcanoes operate on timescales that are almost incomprehensible to a human lifespan. The last major supervolcanic eruption globally was at Yellowstone, roughly 640,000 years ago.
So they sleep for a long time.
A very long time. These systems can exhibit long periods of dormancy, hundreds of thousands of years, punctuated by immense explosive reawakenings. But the magma beneath the Bohemian Massif is deeply buried. It doesn't currently show the rapid upward migration that precedes an actual eruption.
But just knowing it is there fundamentally changes the landscape, doesn't it?
It changes everything from regional infrastructure planning to geothermal energy exploration. But there is a fascinating secondary effect here, too.
What's that?
These deep thermal anomalies subtly influence the surface over millions of years. They create incredibly specific microclimates and soil compositions. Botanists and biologists are now looking at the Bohemian Massif as a unique evolutionary laboratory.
Wait, really? Because of the heat?
Yeah, the hidden heat radiating up, along with the distinct mineral outgassing over millennia, has likely shaped the evolution of local flora and fauna in ways we simply didn't have the context to understand until now.
So the monster in the basement is actually heating the greenhouse. That's incredible. But the crust is just the outermost skin of the Earth. The deep Earth mapping data shows that if we push further down, deep into the mantle, things get even stranger.
Oh, they get much stranger. A newly published global map of Earth's mantle deformation reveals the ghosts of long-lost tectonic plates.
The ghosts of plates.
Yeah, these are massive slabs of ancient crust that subducted or sank beneath other continental plates millions of years ago.
See, I always imagine that when a tectonic plate gets pushed down into the Earth, it just melts into lava and gets recycled into the magma pool.
It's a really common misconception. But the mantle isn't a liquid ocean of magma. It is solid rock that behaves plastically it flows, but over geological eons.
So it's not like dropping an ice cube in hot water.
No, not at all. When a cold, rigid tectonic plate subducts, it doesn't melt immediately. It sinks through the mantle like a giant frozen stone, sinking through incredibly thick hot honey.
Wow.
And as these massive slabs sink, they displace the mantle material around them, driving massive convective currents that literally warp the Earth from the inside out.
So these ancient continents are still intact down there, pushing the mantle around and warping our modern surface.
Yes. The comprehensive seismic data sets show that the vast majority of deep mantle deformation is concentrated precisely where these ancient submerged plates are plummeting toward the core.
And we can see the effects of that on the surface today.
Absolutely. The forces they generate propagate all the way back up. Look at the recent NASA, that's the National Aeronautics and Space Administration, satellite imagery of the Caspian Sea in Azerbaijan.
Right, Azerbaijan is famous for those bizarre mud volcanoes.
Exactly. Azerbaijan has hundreds of them, and some are so massive they actually form entire islands in the Caspian Sea.
But they aren't spewing lava.
No, these aren't your typical lava volcanoes. They are conical structures erupting a slurry of water, mud, and hydrocarbon gases, primarily methane. For a long time, the exact mechanics of their massive size and frequency in that specific region were heavily debated.
But you're saying it's the deep plates causing it.
The sinking of those ancient plates deep in the mantle creates immense localized pressures in the crust above. This tectonic squeezing acts like a giant vice on the deep sedimentary basins of the Caspian.
And those basins are full of old organic stuff, right?
Yes, incredibly rich in decaying organic matter and trapped seawater. So the pressure forces these highly volatile, hydrocarbon-rich slurries up through microscopic fractures in the rock,
Which eventually burst out at the top.
culminating in explosive mud eruptions on the surface. These mud islands are dynamic, they're constantly shifting shape, and they serve as a direct, messy gauge of the crushing, invisible forces operating thousands of miles beneath our feet.
It really paints the Earth not as a static ball of rock, but as this incredibly complex churning engine.
It's very much alive in a geological sense.
Let's bring it much closer to the surface, though. Moving from the crushing pressure of the mantle to, well, the topsoil of New York City.
A very different kind of environment.
Right, because urbanization usually paves over nature, but ecologists just found a massive, thriving ecosystem hiding in the most unexpected place imaginable.
This is a really remarkable ecological study. Entomologists researching the impact of urban sprawl on local pollinators discovered a thriving, incredibly dense population of ground-nesting bees living underneath a cemetery in New York.
I'm sorry, I just have to say, there is a profound, poetic irony to a graveyard being the most vibrant nursery for life in the middle of a concrete jungle.
The irony is very stark, yes. But from an ecological standpoint, the mechanics make perfect sense. Urbanization typically decimates bee populations. You have habitat fragmentation, vast stretches of impermeable concrete paving that prevent ground nesting. Then there's the urban heat island effect, disrupting their foraging cycles, and of course the heavy use of chemical pesticides in suburban lawns and municipal parks.
So the city is basically a hostile architecture for a bee.
Exactly. But a cemetery in the middle of a city is an accidental, pristine sanctuary.
Why? Just because it's quiet?
Cride is a factor, sure, but it's much more about soil mechanics and chemistry. Ground nesting bees require undisturbed, well-drained soil to excavate their brood chambers.
And I guess regular urban parks are just too trampled.
Right, urban parks are constantly compacted by foot traffic and heavy landscaping equipment. Cemeteries experience incredibly low soil compaction. Furthermore, they are essentially massive, continuous green spaces filled with diverse floral landscaping that blooms across different seasons.
Plenty of food, then.
Plenty of food. And crucially, cemetery management typically uses far fewer broad-spectrum chemical pesticides compared to agricultural zones or heavily manicured city parks.
So it's basically a luxury resort for these bees.
The soil composition and the chemical-free environment allow these native bees to flourish in numbers that researchers frankly haven't documented in urban settings before.
It makes you wonder how many species are just holding on in these tiny pockets of undisturbed Earth.
More than we know, probably.
And it's a great reminder that the Earth beneath our cities isn't just hiding biological life, it's hiding our own human story. If we transition from the soil of New York to the soil of Europe, the historical record is currently being completely rewritten by what we are pulling out of the dirt.
It really is an exciting time for archaeology. Let's start at Pembroke Castle in Wales. Archaeologists have been excavating the Wogan Cavern, which sits deep beneath this imposing 11th century medieval fortress.
Okay.
But the monumental discovery they made there had absolutely nothing to do with medieval knights.
What did they find?
Deep in the cavern sediment, they uncovered remains and artifacts dating back roughly 120,000 years.
120,000 years. I mean, that predates the castle, the Romans, the Celts, almost anything we formerly consider civilization in that region.
By orders of magnitude, yes. They found the remains of Neanderthals alongside the butchered bones of extinct creatures, including prehistoric hippopotamuses that roamed the area during a warmer interglacial period.
Prehistoric hippos in Wales. That is wild.
It is. This cave served as a vital strategic refuge. And the real significance emerges when we contextualize this with another breakthrough that just happened in Poland, at the Stocznia Cave.
What did they find in Poland?
An international team successfully extracted and sequenced ancient mitochondrial DNA from 100,000-year-old Neanderthal teeth found in that cave.
Mitochondrial DNA. Wait, that's the DNA passed down exclusively from the mother, right?
Yes, mtDNA is crucial for ancient genetics because it doesn't recombine with the father's DNA. That means it acts as a very reliable molecular clock to trace maternal lineages.
Oh, that makes sense.
It also survives much better in ancient remains because every single cell contains hundreds of mitochondria compared to just one nucleus. By analyzing the mutation rates in this Polish DNA, they discover that these Neanderthals share deep, highly specific genetic connections with other Neanderthal populations spread all across Western Europe and the Caucasus Mountains.
So this whole old stereotype of Neanderthals as these isolated, brutish cavemen who never left their local valley, that is just fundamentally wrong.
It's entirely dismantled at this point. The genetic evidence proves they operated within a vast, interconnected network.
They were travelers?
They were. They migrated across massive geographical distances, they adapted to violent shifts in Pleistocene climates, and they actively shared genetic lineages. It paints a picture of a deeply complex, resilient hominin species that successfully navigated and dominated the Eurasian landscape long before modern Homo sapiens even arrived to compete with them.
It's humbling, really. We keep having to push back the timeline of human complexity.
We do.
And speaking of human complexity, let's fast forward a few tens of thousands of years, the Romans and the Egyptians. I think, for the listener and for myself, we have this tendency to view ancient empires through the lens of marble statues and a Stoic philosophy.
Right. Very grand and formal.
We picture these solemn figures. But the recent archaeological digs are revealing a much messier, much more human reality. Let's look at that Roman tomb discovery in Italy.
Yes, that was fascinating.
Archaeologists excavated a massive 40-foot-long Roman burial structure. But when they breached the inner chamber, it was completely empty of bodies.
An elaborate, highly decorated 40-foot shrine with no physical burials. Initially, it completely baffled the excavation team.
I bet. What was it for?
Well, by analyzing the architectural layout and the residual artifacts, researchers concluded this was not a mausoleum designed to house the dead. It was a dedicated shrine for necromancy and complex ancestor worship.
Necromancy, like as in the literal summoning of the dead.
Yes, exactly. Roman spirituality was profoundly tethered to the afterlife, and it wasn't a passive relationship at all. The boundary between the living and the dead was considered highly porous.
So they thought they could just talk to them.
Ancestral spirits, which they called the manes, were believed to actively watch over the family. They required veneration, appeasement, and during specific festivals like the Lemuria, they were believed to literally walk the earth.
So an empty tomb isn't a missing burial, it's a doorway.
Precisely. It was an architectural portal, a sacred liminal space specifically constructed for the living to conduct rituals meant to summon, consult with, or pacify the spirits of the dead.
That is so intense.
It demonstrates that memory and legacy were not just abstract concepts for the Romans, they were active, sometimes terrifying pursuits that required massive physical infrastructure.
And while the Romans were building portals for ghosts, the Egyptians were apparently dealing with the exact same mundane problems we do today. Let's talk about the discovery in Amarna.
Amarna is a great site.
This was the ancient capital during the reign of the controversial pharaoh Akhenaten. Excavators uncovered a cache of over 43,000 ostraka. What are those exactly?
Ostraka are essentially inscribed pieces of broken pottery or limestone flakes.
So like the ancient equivalent of sticky notes or scrap paper.
That's the perfect way to look at it. Papyrus was a state monopoly. It was incredibly expensive and labor-intensive to produce from reeds.
So normal people couldn't get it.
Right. So for everyday communication, ordinary Egyptians just picked up broken pottery shards and wrote on them with ink. The sheer volume, 43,000 shards, is staggering, but it's the content that is revolutionary.
What was on them?
They contained delivery receipts for grain, mundane ledgers of trade goods, personal notes between neighbors, and a massive amount of schoolwork.
And doodles. So reports mentioned they actually found kids' doodles.
Yes, playful illustrations of animals and people drawn right next to haltingly written alphabet practice.
A kid getting bored in math class and drawing a picture of a dog on their desk. I mean, it's just universal.
It really is. But academically, it indicates that basic functional literacy was likely far more widespread across the social strata of ancient Egypt than we previously assumed.
So it wasn't just the high priests reading and writing.
No, it wasn't exclusively the domain of elite scribes recording monumental state histories. Ordinary tradesmen and children were utilizing the written word daily. The material culture shifts drastically over thousands of years, but the core cognitive drives the need to document trade, the desire to communicate, and the tendency of a student's mind to wander remain entirely static.
It's beautiful, honestly. And there's another Egyptian discovery that perfectly captures that intersection of different cultures. Inside a mummified body from the Roman era, excavated in Oxyrhynchus, Egypt, researchers found a piece of Homer's Iliad physically embedded in the abdomen.
This is a remarkable find from late antiquity, roughly 1,600 years ago. It represents the first time a foundational Greek literary text has been found directly incorporated into the physical Egyptian mummification process.
Why would they put a Greek poem inside an Egyptian mummy?
It physically embodies the intense cultural confluence of the period. You have an indigenous ancient Egyptian funerary rite actively subsuming and utilizing the highest form of Western Hellenistic literature. It was a literal cultural dialogue written onto the flesh.
Wow. From the secrets of antiquity, let's pivot to the secrets of the modern era, specifically the Cold War.
This is quite a pivot.
It is, because the history books just got an incredibly dramatic update regarding one of the most famous maritime discoveries of the 20th century, Robert Ballard's 1985 discovery of the Titanic. It turns out finding the Titanic was a carefully orchestrated smokescreen.
This declassification completely alters the historical narrative we all grew up with. For decades, the public believed Ballard, this passionate civilian oceanographer, was leading a privately backed scientific crusade to find the tragic passenger liner.
But that wasn't the real mission.
No. The newly discussed military records reveal that the entire expedition was a top-secret, highly classified operation funded and strictly directed by the United States Navy.
If they weren't looking for the Titanic, what were they actually hunting for?
2 lost Cold War nuclear attack submarines. The USS Thresher, which sank in 1963, and the USS Scorpion, which was lost in 1968.
Oh, wow. Nuclear subs.
Both imploded at extreme depths under very mysterious circumstances, taking their crews, their nuclear reactors, and highly sensitive cryptographic equipment to the ocean floor. The Navy desperately needed to locate the wreckage fields to assess the environmental state of the nuclear reactors.
And to make sure nobody else got to them first.
Exactly. More importantly, to determine if Soviet forces had tampered with the wrecks.
But you can't just sail a massive fleet of high-tech Navy research vessels into the North Atlantic without the Soviets noticing, right?
You can't. You need a cover story big enough and civilian enough to explain why you are deploying deep-sea submersibles and advanced acoustic arrays to that specific area.
So they used the Titanic as an alibi.
The Navy approached Ballard, who was struggling to secure civilian funding, to test his revolutionary deep-sea robotic camera sled, the Argo. A symbiotic deal was struck. The Navy would fund the expedition and provide the ships.
Yeah.
In return, Ballard would use Argo to secretly map the debris fields of the Thresher and the Scorpion.
So the Titanic was just a side quest.
The Navy explicitly told him that if he accomplished the primary military objectives and had any operational time left over, he was free to look for the Titanic.
And the wild part is he finished mapping the nuclear subs and actually found the Titanic with only 12 days left in the mission. It's wild that Ballard used a scientific smokescreen to hide a military operation, but that same blurring of lines, military maneuvering disguised as civilian or commercial activity, is exactly what we are watching unfold right now in the Strait of Hormuz.
The transition from Cold War espionage to modern geopolitical choke points is highly relevant here. We are currently observing a severe, rapidly escalating standoff between the United States and Iran in the Strait of Hormuz.
Which is arguably the single most critical artery for global energy. It's a narrow waterway, only about 21 miles wide at its narrowest point, separating the Persian Gulf from the Gulf of Oman.
It's a massive bottleneck.
A massive percentage of the world's liquefied natural gas and oil passes through that tiny gap. And right now, the tension there is threatening to snap. U.S. President Donald Trump extended a fragile 2-week ceasefire regarding naval operations, but the diplomatic rhetoric is incredibly aggressive.
It is.
He publicly warned that if the upcoming multilateral peace talks in Islamabad fail to yield an agreement, lots of bombs start going off.
And Iran has adopted a stance of absolute defiance. Mohammad Baker Ghalibaf, Iran's chief negotiator and the speaker of their parliament, explicitly stated that Tehran will not engage in diplomacy under the shadow of military threats.
So neither side is backing down.
No. He warned that Iran is prepared to fundamentally alter its battlefield strategies, signaling that they possess asymmetric military options they have yet to deploy if the U.S. pressure campaign continues.
And it has already moved past rhetoric into kinetic action. U.S. naval forces actively intercepted and seized an Iranian-flagged oil tanker, the Tuska.
The justification from Washington is that the Tuska was operating in direct violation of international sanctions, illicitly transferring sanctioned crude oil. Almost concurrently, presumably in retaliation or as a parallel demonstration of area denial, Iranian forces attacked a commercial container ship transiting the strait.
Attacked a civilian ship.
Reports indicate warning shots were fired at 3 separate vessels, though thankfully no casualties among the civilian crews have been reported yet.
But the immediate consequence is that commercial shipping companies are terrified. Transit through the strait has ground to a near standstill. The government of Kuwait just took an extreme step. They declared force majeure on their international oil shipments.
Which is the ultimate red flag in global commodities.
Explain that for us.
When a sovereign nation declares that the geopolitical environment is so volatile that they physically cannot guarantee the safe passage of their primary export, it sends immediate shockwaves through the global supply chain.
Let's track that shockwave for the listener. How does a naval standoff in the Middle East actually hit the wallet of someone listening to this deep dive in London or Tokyo or New York?
The cascade is instantaneous. The moment a threat level rises in the strait, maritime insurance premiums for commercial vessels skyrocket. When ships avoid the strait entirely, they have to reroute around the Horn of Africa,
Which takes way longer.
adding weeks to transit times and burning massive amounts of extra fuel. We are already seeing the macroeconomic response. Global equity markets, including the Dow and NASDAQ, slipped significantly today, while crude oil futures spiked.
And the Association of German Chambers of Industry and Commerce issued a very stark warning today about what this means for European manufacturing.
Yes, they warned that German industrial firms are facing immense structural cost increases. Germany's heavy industry is highly energy intensive.
So if oil goes up, everything goes up.
Exactly. When the base price of fuel rises, the cost to operate the factories rises. The cost to manufacture chemicals, steel, and consumer goods surges. This imported inflation ripples outward, forcing companies to pass those costs directly onto consumers.
Ultimately, a standoff over a tanker in the Persian Gulf dictates the price of groceries and heating bills across the European Union.
It's all connected.
When you look at the maneuvers here, you have two very different strategic doctrines colliding.
Analyzing this impartially, we see a textbook clash of strategic timelines. The United States, under the current administration, is executing a strategy of maximalist deterrence.
Meaning they want a quick resolution.
The goal is rapid capitulation. They are utilizing blunt public warnings and swift kinetic enforcement actions like the seizure of the Tuska to apply overwhelming immediate pressure, attempting to force Iran back to the negotiating table on U.S. terms.
Whereas Iran's strategy seems to be built entirely on attrition.
Iran is playing a calculated asymmetric long game. Their strategic doctrine relies on strategic endurance. By refusing to capitulate to direct threats and simultaneously demonstrating their capability to cripple global commercial shipping at will, they are attempting to generate widespread international economic pain.
Hoping the rest of the world blinks first.
Their calculation is that the cascading inflation and supply chain disruptions will eventually force the broader international community to pressure the U.S. into offering more favorable diplomatic terms. It is an incredibly dangerous, high-stakes test of economic and military resolve.
And while the Middle East is flashing red, the political architecture of Europe is quietly being rewired. Look at the election results out of Bulgaria.
Bulgaria just concluded a highly polarized election, resulting in a decisive victory for Rumen Radev, who is widely recognized as a pro-Russian political figure.
Which is a massive geopolitical wedge, considering Bulgaria is a member of both NATO and the European Union.
It creates profound internal friction within both alliances. Radev's incoming coalition is explicitly expected to pursue closer economic and diplomatic ties with Moscow. This complicates unified European policy regarding Russian energy dependence, economic sanctions, and the broader security posture of NATO's eastern flank.
And you can see how deeply that threatens the rest of Europe by looking at Germany's immediate reaction. The German defense minister, Boris Pistorius, just laid out a new national military strategy that basically sets 80 years of German foreign policy on fire.
It is a monumental historic pivot. Since the end of the Second World War, Germany has operated under a strict doctrine of post-war pacifism, structurally hesitant to project military power or lead European defense initiatives.
And now,
Pistorius explicitly dismantled that doctrine today. He stated unequivocally that Germany must now assume a leading, proactive role in European security.
they are essentially saying the American security umbrella is no longer guaranteed and the threats on our borders are real. We have to rearm.
Exactly. They're committing to a massive structural rebuild of the Bundeswehr, their armed forces. The geopolitical plates of the 20th century are actively fracturing, forcing nations to rapidly abandon legacy doctrines to prepare for a much more muscular, contested global environment.
But while nations are fighting over shipping lanes and border security, there is an entirely different arms race happening right now. It is invisible, it is measured in hundreds of billions of dollars, and the weapon of choice is artificial intelligence. Let's shift our deep dive into the technology sector, because the scale of what is happening in AI right now just defies comprehension.
We are witnessing the largest, most aggressive capital allocation in the history of the technology sector. It is quite literally a trillion-dollar proxy war for the future of computation.
I was reading the financial data for this, and the numbers are so astronomical they literally stop feeling like money. Amazon just finalized a $5 billion investment into an AI research lab called Anthropic.
That's a huge sum.
And in return, Anthropic committed to spending $100 billion with a B on Amazon Web Services cloud computing infrastructure over the next several years. I mean, $100 billion on cloud computing. That's not a software subscription. That is the GDP of a sovereign nation.
It perfectly illustrates the brutal physical reality of the AI revolution. Creating artificial general intelligence is not just a math problem. It is an industrial infrastructure problem.
Explain that.
You are not just paying engineers to write elegant code. Training foundational large language models requires orchestrating tens of thousands of advanced graphical processing units. You have to house them in massive data centers and pay for the immense electrical power required to run and cool them.
So Amazon is essentially acting like the bank and the landlord. They give Anthropic the cash, but Anthropic has to spend it renting Amazon's computers.
It's a closed-loop ecosystem. It's designed to lock Anthropic in as the foundational tenant of AWS, positioning Amazon to compete directly against Microsoft's partnership with OpenAI.
And speaking of OpenAI, they are relentlessly pushing the envelope. They just dropped GPT 5.5.
which represents a significant architectural leap. The 5.5 parameters drastically improve the model's contextual latency,
Meaning what, exactly?
meaning it can process highly complex, multi-step logical reasoning tasks across vastly different data formats, integrating raw code, financial data, and natural language simultaneously. Even more impressively, their updated ChatGPT Images 2.0 architecture has crossed a major threshold.
Oh, the text thing.
Yes, it is now generating highly legible, flawless text within its generated images.
Which is huge because that used to be the ultimate AI tell. You would prompt it to draw a coffee shop and the sign on the window would look like melting alien hieroglyphics.
Right. The inability to render text was a fundamental flaw in how early diffusion models conceptualized pixels versus semantic meaning. Solving that blends natural language understanding directly into the visual generation matrix. It will profoundly disrupt commercial graphic design, advertising, and synthetic media creation.
But there is a massive wall approaching, isn't there? The software is getting smarter, but the physical hardware is basically buckling under the strain.
The bottleneck of the AI era is physical physics, specifically thermodynamics and energy transmission. The energy consumption of global AI data centers is on a parabolic trajectory that threatens to destabilize regional power grids.
But the hardware engineers are fighting back. There is a breakthrough detailed here regarding a new brain-like chip.
This is a phenomenal advancement in neuromorphic engineering. An international team has developed a novel microchip utilizing a modified transition metal called hafnium-oxide.
Hafnium-oxide.
Yes. To understand why this matters, we have to look at how traditional computers work. Almost all modern computing uses the von Neumann architecture, which physically separates the central processing unit from the memory storage.
Right. It's like having the kitchen on the first floor of a house and the pantry on the third floor. If you want to cook a meal, you have to constantly run up and down the stairs for every single ingredient.
A perfect analogy. In a computer, constantly shuttling data back and forth between the CPU and the RAM across the motherboard creates what we call the von Neumann bottleneck. It wastes an agonizing amount of time and generates massive amounts of heat through electrical resistance.
So how does the hafnium-oxide fix the kitchen?
It creates what are called memristors, resistors with memory. This chip mimics the synaptic structure of the human brain, where computation and data storage happen simultaneously in the exact same physical location.
So the pantry and the kitchen are in the same room.
Exactly. Hafnium oxide can change its electrical resistance based on the current passing through it, and it remembers that state even when the power is off. By eliminating the need to transit data back and forth, this neuromorphic chip reduces the energy required to run complex AI algorithms by a staggering 70%.
A 70% reduction in power consumption. I mean, if you scale that across the industry, you completely neutralize the energy crisis, you solve the cooling problem, you stabilize the power grid, and you allow AI models to grow exponentially larger without requiring a dedicated nuclear power plant just to run them.
The implications are vast.
And it's not just experimental materials. The major players are throwing down. Google Cloud just unveiled 2 new proprietary TPU chips, tensor processing units designed specifically to challenge NVIDIA's absolute monopoly on AI hardware.
The silicon war is just as fierce as the algorithm war. And when you combine this escalating hardware efficiency with advanced models, something profound happens. AI ceases to be a novelty generator of text and images and becomes an autonomous engine of scientific discovery. AI is no longer just mimicking reality, it is decoding it.
Case in point, a system called GeoFlow. This is an AI that is currently mapping hidden structures in the ocean.
GeoFlow stands for geostationary ocean flow. Oceanographers trained a deep learning neural network on decades of raw thermal imaging data captured by existing weather satellites.
Satellites that are just looking at the surface temperature of the water.
Correct. But the AI learned to detect unimaginably subtle microfluctuations in those surface temperatures over time. By tracking those thermal signatures, the AI successfully mapped sub-mesoscale ocean currents.
Sub-mesoscale, what does that actually mean?
They are small, incredibly complex, chaotic whirlpools and eddies that exist just below the surface. They are too small and fast-moving to track with traditional oceanic buoys or research vessels.
But they are important.
They are absolutely critical to the planet's biosphere. They regulate global heat distribution, they transport vital nutrients for phytoplankton, and they sequester massive amounts of atmospheric carbon into the deep ocean. GeoFlow allows it to track this invisible vascular system of the Earth globally, in real time, using data we were already collecting but lacked the mathematical capacity to understand.
And it gets even more fundamental than mapping ocean currents. An AI just discovered new physics. It found a behavior in matter that breaks our classical understanding of how the universe works.
This occurred in the study of dusty plasma, which is considered the fourth state of matter. Plasma is a superheated gas where electrons are stripped from their atomic nuclei, creating a highly electrically charged fluid.
Okay, so what is dusty plasma?
Dusty plasma introduces microscopic solid particles into that chaotic environment. It is found everywhere from the rings of Saturn to the center of experimental fusion reactors. It is mathematically incredibly volatile.
So physicists pointed a neural network at this chaos. What did the AI find?
It identified the existence of non-reciprocal forces. In classical mechanics, Newton's third law dictates that every action has an equal and opposite reaction. If particle A pushes on particle B with a certain force, particle B pushes back on particle A with the exact same force.
That's like the baseline rule of physics.
But the neural network, by tracking the three-dimensional interactions of millions of particles in the plasma, proved that in this specific state, the symmetry breaks.
Breaks how?
Because the surrounding plasma acts as an active flowing energy reservoir, particle A can exert a massive force on particle B, while particle B exerts almost zero force back on A.
It's like pushing someone on a swing, but you don't feel any resistance against your hands.
Exactly. It upends our intuitive assumptions about physical mechanics. And the revelation here isn't just the physics, it's the method. AI has transitioned from an administrative assistant to a lead theoretical researcher. It is capable of looking at raw, chaotic data, performing dimensional analysis, and extracting fundamental laws of nature that human cognition simply could not isolate.
It's a complete paradigm shift. We are upgrading the intelligence of our machines at breakneck speed. But here is where it gets highly personal. We are simultaneously learning how to radically upgrade and defend our own biology.
Yes, the medical tech is advancing just as fast.
Let's transition into the medical and health breakthroughs, starting with an incredible innovation in the fight against infectious diseases. Scientists at Queen's University Belfast have engineered a flexible plastic film that literally destroys viruses upon contact.
It's a brilliant application of material science. The film is constructed from low-density polyethylene, or LDPE.
Which is just standard, cheap plastic the stuff grocery bags are made of.
Yes, but the innovation lies in what is embedded within the polymer matrix. Titanium dioxide nanoparticles. Titanium dioxide is a photocatalyst.
Meaning it reacts to light.
Yes. When this plastic film is exposed to ultraviolet light, and it doesn't require high-intensity clinical lasers, even ambient UV from standard fluorescent lighting or sunlight works that titanium dioxide absorbs a photon. This excites an electron, causing it to jump the atomic band gap, which leaves behind a positively charged hole.
Okay, we're getting deep into the chemistry. What does that positively charged hole actually do to a virus?
It reacts violently with the ambient water molecules and oxygen in the air, tearing them apart to generate highly reactive oxygen species, primarily hydroxyl radicals.
And those are bad news for viruses.
They are incredibly aggressive chemical scavengers. When a viral droplet lands on the plastic, these radicals instantly attack the lipid envelope, the protective fatty outer shell of the virus. They rip the electrons away from the viral structure, completely disintegrating it and denaturing the genetic payload inside.
In the lab tests, it destroyed up to 94% of the viral load of influenza and SARS-CoV-2 in under an hour. Think about the physical applications here. You could apply this self-sterilizing film to subway poles, hospital waiting room chairs, airplane tray tables, elevator buttons.
It transforms passive, high-transmission surfaces into active, microscopic minefields for viruses.
It represents a structural shift in public health, moving from chemical disinfection, which is temporary and labor-intensive, to passive, continuous environmental sterilization.
Exactly.
That is an amazing external defense. But the sources show that life has also evolved incredibly complex internal genetic defenses. There is a new study out regarding bacterial immune systems that is frankly blowing my mind.
It forces a rewrite of standard evolutionary genetics, frankly. Biologists have discovered that certain strains of bacteria possess the ability to synthesize completely brand new DNA from scratch to defend against bacteriophages, which are viruses that hunt bacteria.
Okay, let's pause here. Basic biology taught me that DNA replicates. It unzips, and enzymes like polymerase come in and strictly copy the existing genetic template. You're saying these bacteria aren't copying, they are inventing.
That is the crux of the discovery. Historically, we understood bacterial immunity through systems like CRISPR.
Right, the gene editing thing.
Yeah, where the bacteria acts like an archivist, snipping a tiny fragment of an attacking virus's DNA and storing it in its own genome as a memory to fight future infections. It was an elegant cut-and-paste mechanism.
But this new mechanism is entirely different.
Yes. They discovered a highly specialized reverse transcriptase enzyme. Instead of copying an existing template, this enzyme actively synthesizes novel, incredibly long genes de novo DNA sequences that have never existed before in nature. The bacteria is essentially writing bespoke genetic code on the fly to produce novel defense proteins that neutralize the invading virus.
If a single-celled organism can dynamically write new DNA to survive a threat, what happens if human scientists figure out how to harness that exact enzyme?
The therapeutic implications are virtually limitless. Current gene therapy, even advanced CRISPR-Cas9, is largely limited to editing, deleting, or splicing existing genetic material.
So we are just proofreading right now.
Exactly. If we can adapt this bacterial mechanism of de novo synthesis, we could potentially design and program entirely new genetic sequences directly into human cells to combat highly mutable viruses, target complex autoimmune diseases, or repair severe genetic degradation.
And we are already exponentially improving how we deliver genetic instructions. There's another finding here involving a tiny modification to mRNA therapies.
Researchers achieved a massive breakthrough in the delivery vectors for messenger RNA. mRNA therapies, like the COVID-19 vaccines, use lipid nanoparticles, tiny spheres of fat, to protect the fragile genetic instructions as they travel through the bloodstream and breach the target cell's membrane.
But they aren't perfectly efficient, right? A lot of the mRNA gets degraded before it can do its job.
Exactly. But biochemical engineers discovered that by conjugating or attaching a highly specific, simple sequence of just 3 amino acids to the surface of these lipid nanoparticles, they fundamentally altered how the human cells interact with the particle.
What was the result?
It catalyzed a 20-fold increase in translational efficiency.
A 20-fold increase. That is a 2,000% boost in effectiveness.
The 3 amino acid tag essentially acts like a VIP access badge. It drastically accelerates how quickly the cell absorbs the nanoparticle and how efficiently the ribosomes read the mRNA to manufacture the desired therapeutic proteins.
So we need way less of the drug to get the same effect.
This means we could administer mRNA cancer vaccines or targeted genetic therapies at radically lower doses, which minimizes toxic side effects while maximizing the clinical outcome.
Okay, we've covered eradicating global viruses and reprogramming DNA. Now let's tackle the ultimate existential threat that plagues humanity: baldness.
A very different kind of problem.
Seriously, though, there's a fascinating clinical study here about curing androgenic alopecia.
It is a remarkable example of finding therapeutic value in fundamental biochemistry. Researchers investigating tissue regeneration discovered that a naturally occurring sugar called deoxyribose severely stimulates hair regrowth.
Wait, deoxyribose as in in DNA?
Precisely the same molecule. Deoxyribose is the foundational 5-carbon sugar that forms the structural backbone of every DNA strand in your body. In studying its effects on wound healing, scientists formulated a topical gel infused with the sugar and applied it to the skin.
And what happened?
They found that it triggers massive, localized angiogenesis.
Angiogenesis, meaning the physical creation of new blood vessels.
Yes. The deoxyribose signals the surrounding tissue to rapidly construct a dense network of new capillaries, specifically around the dormant hair follicles.
And more blood flow means an influx of oxygen and nutrients waking the follicle up.
Exactly. In marine models, the application of the deoxyribose gel resulted in a 60% increase in active hair regrowth. That efficacy directly rivals minoxidil, which is the leading FDA-approved pharmaceutical treatment for hair loss globally.
But minoxidil has drawbacks, right?
Significant drawbacks. Minoxidil was originally developed as an oral medication for severe hypertension. Even when applied topically, it can cause severe scalp inflammation, contact dermatitis, and systemic cardiovascular side effects like rapid heart rate.
Wow, okay. And the sugar gel doesn't do that.
Deoxyribose, conversely, is a simple endogenous sugar that the human body already produces and metabolizes flawlessly. It represents a highly potent, entirely natural alternative without the pharmaceutical toxicity.
It's amazing. The cure for baldness might literally just be rubbing the sugar backbone of DNA on your scalp. Why do these massive multi-billion-dollar medical puzzles sometimes have the most rudimentary biological answers?
Because nature has been running relentless, brutal research and development for 4 billion years, the biochemical architecture is already perfectly optimized. We are simply stumbling around in the dark trying to find the right master keys to unlock the specific doors we want to open.
Which serves as the perfect conceptual bridge for our final segment. From the microscopic architecture of sugars and DNA, we are finally casting our gaze outward, because the exact same physical and chemical forces shaping our biology and our planet are currently playing out on a staggering cosmic scale. Let's look up to the solar system and beyond. Let's start with Mars.
The planetary science community is experiencing a paradigm shift regarding the hydrological history of Mars. The evidence that it was once a wet, dynamic, and potentially habitable world is no longer circumstantial. It is overwhelming. Orbital topography has identified a massive geological boundary that functions exactly like a bathtub ring.
A bathtub ring on a planetary scale, meaning the ancient shoreline of a massive body of water.
An immense body of water. The geological mapping suggests this shoreline demarcates an ancient northern ocean that, at its peak, may have covered a full third of the Martian surface.
A third of the planet underwater. It basically looked like Earth.
It possessed the fundamental solvent for life. And we are finding much more than just the ghost of an ocean. NASA's Curiosity Rover, which is currently climbing Mount Sharp in Gale Crater, deployed its percussive drill into a mudstone target, nicknamed Mary Anning 3.
And what did it find in the rock?
The chemical analysis of the powder pulled from that rock revealed the most complex, diverse array of organic molecules ever identified on another planet. Most critically, they isolated nitrogen heterocycles.
Okay, unpack that. Why are nitrogen heterocycles the smoking gun?
A heterocycle is a ring-shaped molecular structure containing carbon and at least one other element, in this case nitrogen. On Earth, these specific nitrogen-carbon rings form the nucleobases adenine, guanine, cytosine, and thymine. They are the physical letters of the genetic alphabet.
Oh, wow.
Their unique shape is what allows them to bond together like a zipper, forming the double helix of DNA and RNA.
So we literally found the specific alphabet letters required to write the code of life buried in a Martian rock.
We found the exact chemical precursors required for terrestrial biology. Additionally, the European Space Agency's Mars Express orbiter recently captured high-resolution imagery of ancient volcanic ash formations being sculpted by the wind across the Martian surface.
Meaning there were active volcanoes.
It serves as a stark reminder that Mars wasn't just wet, it was geologically hot and violently active, possessing the thermal energy necessary to catalyze those chemical precursors into complex biology.
Okay, I have to push back here because this is maddening. We have mapped a global ocean. We have confirmed rampant volcanic heat. We have literally drilled into a rock and extracted the exact nitrogen rings needed to build DNA. At what point does the scientific community stop hedging and just admit that the cosmic house was fully built and we simply missed the original tenants?
It is the most profound, agonizing question in astrobiology. We have undeniably found the blueprints, the bricks, and the mortar. The entire chemical staging ground for life was present. But the leap from complex organic chemistry to actual self-replicating biology is a monumental one.
So we need a fossil.
We have not yet found a fossilized microbe. Answering definitively whether that spark occurred is the primary mandate for the Perseverance rover, which is currently caching samples, and the upcoming Mars sample return mission, which aims to bring those rocks back to terrestrial labs.
And we are rapidly building the infrastructure to go answer these questions in person. Humanity's return to deep space is accelerating. Let's look at the Artemis program.
NASA's Artemis architecture is achieving critical milestones. Comprehensive engineering assessments from the uncrewed Artemis first mission and the hardware tests for Artemis II confirmed that the Orion spacecraft's thermal protection systems, the heat shield, performed flawlessly during the brutal re-entry into Earth's atmosphere.
Which is pretty important if you want to put people in it.
This guarantees the structural safety required for crewed lunar missions.
But Artemis III is the actual moonshot. That is the mission scheduled for 2027 that will put boots back on the lunar regolith.
And the physical reality of that mission is taking shape. The Space Launch System, or SLS, is the super heavy lift launch vehicle designed to carry Orion. The massive 212-foot-tall core stage for the Artemis III rocket has officially completed manufacturing at the Michaud Assembly Facility in New Orleans.
And it's moving now.
It is currently being barged to the Kennedy Space Center in Florida for final integration. It is a staggering feat of aerospace engineering.
And it's not just crude exploration. NASA is preparing to fundamentally alter how we see the universe with the Nancy Grace Roman Space Telescope, targeting a launch in September 2026.
The Roman Space Telescope is a cosmological game changer. It is an infrared observatory, but unlike the Hubble Space Telescope, which acts like a soda straw peering deeply into a tiny fraction of the sky, Roman has a field of view 100 times wider than Hubble.
So it sees the big picture.
Over its primary 5-year mission, it will sweep the cosmos, generating a colossal 20,000 terabyte data archive. Its primary directives are to map the distribution of dark matter, measure the effects of dark energy on the expansion of the universe, and utilize microlensing to discover hundreds of thousands of new exoplanets.
And speaking of exoplanets, the James Webb Space Telescope JWST, which is already out there operating, just found something that sounds like it belongs in a sci-fi novel.
JWST continues to shatter our astrophysical models. It recently utilized its coronagraph, an instrument that physically blocks the blinding light of a host star, to directly image an exoplanet called Epsilon Indiab.
Where is that?
This is a gas giant located roughly 12 light-years from Earth. What makes it extraordinary is that it is the coldest exoplanet ever directly imaged, with an atmospheric temperature of approximately 275 Kelvin.
275 Kelvin, that is just barely above the freezing point of water on Earth.
Exactly. It's roughly 35 degrees Fahrenheit. And spectroscopic analysis of its atmosphere revealed something breathtaking: the presence of high-altitude water ice clouds.
Clouds made of literal ice crystals drifting through the atmosphere of a gas giant in an alien star system. That is visually stunning.
It radically challenges our understanding of atmospheric chemistry on substellar objects and proves how wildly diverse planetary systems can be. But the truth is, we don't even have to look 12 light-years away to find physics that break our brains. We just have to look at the outer edges of our own solar system. Let's talk about the ice giants, Uranus and Neptune.
They really feel like the forgotten planets. We talk about Mars and Jupiter constantly, but Uranus and Neptune are just mysteries.
They are enigmatic because of their extreme distance. We haven't sent a dedicated close proximity probe to either planet since the Voyager 2 flybys in the late 1980s. Consequently, our understanding of their deep interiors has been largely theoretical.
But the math is showing us something new.
Yes. Astrophysicists running highly advanced quantum-level computer simulations now believe a bizarre, highly exotic state of matter exists deep inside both planets, known as supersonic water.
Supersonic. What exactly happens to water to make it supersonic?
You have to imagine the environment deep inside the mantle of an ice giant. The pressure is millions of times greater than the atmospheric pressure at sea level on Earth, and the ambient temperature reaches thousands of degrees.
Extreme conditions.
Under these incomprehensibly extreme conditions, the molecular bonds of water, H2O, and various hydrocarbons are violently crushed. The simulation dictates that the oxygen and carbon atoms crystallize, locking together to form a rigid, highly dense, solid lattice structure, much like a diamond.
Okay, so the heavy atoms turn solid. What happens to the hydrogen?
The hydrogen protons decouple from the oxygen. They are stripped away and enter a supersonic phase, where they flow freely through the microscopic gaps in the solid carbon-oxygen lattice, behaving entirely like a liquid.
Wait, so it is simultaneously a solid and a liquid. It's a solid diamond-like cage with liquid hydrogen physically flowing through the bars.
Yes. It is a true hybrid phase of matter that cannot exist naturally on Earth, and the implications are massive. Because hydrogen protons carry a positive electrical charge, this massive, planet-wide flow of liquid protons generates an immense electrical current,
which creates a magnetic field.
This supersonic dynamo effect perfectly explains the highly unusual, wildly off-center and tilted magnetic fields that Voyager 2 measured surrounding both Uranus and Neptune, a mystery that had baffled planetary scientists for 40 years.
That is absolutely wild. The physics of the universe are just infinitely weirder than we give them credit for. And that brings us to the final source today, which might be the most paradigm-shattering concept we've discussed. A NASA scientist is formally proposing that modern physics might be missing an entire fundamental force of nature.
This touches on the theoretical search for the fifth force. To contextualize this, the standard model of physics currently recognizes 4 fundamental forces that govern all interactions in the universe.
Right. Gravity is one.
You have gravity, which attracts mass. You have electromagnetism, which governs light and magnets. You have the strong nuclear force, which binds protons and neutrons together inside an atom. And you have the weak nuclear force, which is responsible for radioactive decay.
But those 4 forces, as complete as they seem, cannot explain everything we observe in the cosmos.
They fail spectacularly when confronted with the largest scale of the universe. Specifically, they cannot account for dark energy. Astronomical observations unequivocally prove that the expansion of the universe is accelerating. Galaxies are flying apart faster and faster.
And gravity should be stopping that.
Gravity should be pulling everything back together, slowing the expansion down. But some massive unseen pressure, which we mathematically placeholder as dark energy, is overpowering gravity.
So how does a fifth force solve the dark energy problem?
The proposition centers around a theoretical concept called quintessence. Unlike Einstein's cosmological constant, which assumes dark energy is just a static, unchanging property of empty space, quintessence suggests that dark energy is a dynamic, evolving scalar field.
So it's an active player.
It is a fifth active fundamental force that interacts with matter in incredibly subtle ways that we haven't possessed the instrumental precision to measure.
Where are they looking for it?
A NASA researcher has proposed that if quintessence exists, its subtle interactions would create microscopic gravitational anomalies. They are currently analyzing decades of highly precise orbital tracking data from near-Earth asteroids, looking for minuscule deviations in their trajectories, tiny, unexplained tugs or accelerations that Newton's laws and Einstein's general relativity simply cannot account for. If they find those deviations, it would be the first empirical footprint of a fifth force.
And that idea right there ties this entire deep dive together perfectly. Just think about the scale of what we've covered today. From the hidden 3,000 square kilometer supervolcano slumbering beneath Europe, to the invisible tectonic plates warping the mantle, to the AI discovering non-reciprocal physics and chaotic plasma. There are fundamental structural rules of reality operating right in front of our faces, and we are only acquiring the scientific lenses required to perceive them.
We are entirely surrounded by an invisible architecture. Whether we are discussing geological deep time, the biochemistry of a single bacterial cell, or the cosmological forces expanding the universe, reality is infinitely more complex, layered, and strange than our current textbooks suggest. The map is not the territory. We are still drawing the map.
It has been a truly massive journey today. We started with ancient Neanderthals navigating Ice Age Europe, completely unaware of the DNA networks binding them together. We watched modern AI reason through the chaos of ocean currents, and we saw a simple sugar molecule trick the human body into growing new blood vessels. We looked at the superionic liquid flowing inside the ice giants and the hidden military maneuvering happening right now in the world's most critical waterways. I want you, the listener, to pause and reflect on how much of the world you navigate every single day operates completely out of sight. The ground beneath your feet, the invisible code in your devices, the silent sky above your head, it is all humming with secrets.
And to leave you with one final provocative thought regarding the limits of our perception. We spent today talking about hidden forces and the rules that govern reality. Just recently, a team of mathematicians managed to shatter a 150-year-old geometric rule regarding donut-shaped surfaces.
Wait, donuts?
Yes. They proved, through sheer mathematical rigor, that two highly complex shapes can look absolutely completely identical on a local close-up level, but possess an entirely fundamentally different global structure. It proves that our local perspective can be a total illusion.
Oh, I see where you're going with this.
If a fifth force is hiding in the orbital math of our solar system, and hidden superionic states of matter are generating planetary magnetic fields, what hidden potentials, what entirely undiscovered dimensions of thought and physics exist within our own minds that we simply haven't discovered the math to unlock yet?
That is the absolute perfect question to end on, because the X-ray machine of human knowledge is constantly being upgraded, and the murky waters of reality are slowly, surely clearing. So what does this all mean? It means the deep dive never really ends. There's always another layer beneath the surface. Thank you for exploring the hidden world with us today. Keep asking questions, keep looking past the obvious, and we will catch you on the next one.
For enjoying Artificially Informed.
Hit subscribe and share it with a friend.
From the left, the right, and straight from the algorithm.
Thank you.
Welcome to The Debate. Right now, if you were to look at satellite imagery of the Arabian Sea, you would see dozens of massive commercial vessels just, idling in the water.
Yeah, just sitting there, completely stalled out.
Exactly. And thousands of miles away in South Korea, chemical plants are quietly throttling down their production lines. And across the agricultural belts of India, farmers are looking at the price of fertilizer and realizing they literally can't afford to plant this season's crops.
Right, and it is incredibly easy to look at these isolated events, to look at the ongoing U.S.-Iran conflict and the blockade in the Strait of Hormuz, and just conclude that the world is falling apart.
It really is. But today, we're pulling back the lens. We're looking at this from a planetary perspective, drawing on a comprehensive review of recent global reporting, financial data, and diplomatic dispatches spanning from Latin America all the way to Asia.
Because we consider the planet our home, not just the US or the West.
Well said. And from where I sit, these disruptions actually reveal the exact opposite of a collapse. I mean, they reveal a global financial and diplomatic system demonstrating remarkable resilience, absorbing a massive geopolitical shock without breaking the established US-led world order.
See, I have to strongly disagree with that framing. When you look at the physical realities of global supply chains breaking down, and you pair that with the, frankly, unprecedented diplomatic realignments happening right now in the global south and Europe.
You don't think the system is absorbing it?
No, absolutely not. You aren't seeing a system absorbing a shock. You're watching the definitive end of unipolar hegemony. We are witnessing the very real structural fragmentation of our planet into a multipolar world.
Okay, well, let's start with the economic picture, because if the system were truly fracturing, I mean, the financial markets would be the first to sound the alarm, right?
You would think so, yeah.
Right. And we have Brent crude oil topping $100 a barrel. We have severe ongoing military tensions in, arguably, one of the most critical energy corridors on Earth.
The most critical, I'd say.
Fair enough. By all historical metrics, a disruption of this magnitude in the Strait of Hormuz should send the global economy into an absolute tailspin. Yet, what is actually happening?
Well, the S&P 500...
The S&P 500 and the NASDAQ recently hit record highs following the U.S.-brokered 3-week ceasefire extension. That isn't just blind optimism, you know. That is the global market dynamically pricing in the disruption and calculating that the core economic framework holds.
I think you're looking at financial abstractions, though, stock indices and loan approvals, but the system is literally fracturing on a physical, tangible level.
But established diplomatic and financial institutions are executing exactly what they were designed to do. I mean, the U.S. Treasury is actively organizing financial support to stabilize our Gulf allies.
Sure, but...
And in Europe, the EU just successfully navigated internal politics to approve a massive 90 billion euro loan to Ukraine, while successfully unblocking the Druzhba pipeline to keep oil flowing. The system is stressed, absolutely, but it's bending, it's not breaking.
Wall Street can price in a disruption, but you cannot print a physical chemical molecule out of thin air. The Strait of Hormuz blockade is not just a localized energy issue.
No, it's a major choke point, obviously.
It's an irreplaceable choke point that is breaking the physical supply chains the modern world relies on.
But those supply chains are finding alternative routes. I mean, markets adapt. That's what they do.
They aren't just finding new routes. They are stalling out entirely. Let's look at the mechanics of this. Take naphtha, for example.
Okay, naphtha.
For anyone's unfamiliar, naphtha is a highly volatile, flammable, liquid hydrocarbon mixture. It is the foundational petrochemical feedstock for almost all modern manufacturing.
Right, it's in everything.
Exactly. It's the base of the plastics in our medical devices, our automotive parts, our electronics. And because of the blockade, the physical flow of naphtha has been severed.
Which has caused disruptions, yes.
It's forced South Korea's LG Chem, which is one of the largest chemical companies on Earth, by the way, to literally shut down production lines. Or look at urea fertilizer.
Right, the India situation.
Yeah, urea production requires massive amounts of natural gas. With the strait restricted, natural gas shipments are delayed or rerouted, and as a result, the price of urea in India has doubled. We are talking about food security for over 1 billion people here.
It's a severe shock, I agree.
And Germany, the economic engine of Europe, has just halved its 2026 growth outlook specifically because of soaring structural energy costs. This physical fracturing threatens to bring the actual, tangible global economy to a standstill, regardless of how irrationally exuberant the S&P 500 happens to be today.
I mean, I see why you think that, but let me give you a different perspective. I think you're mistaking a severe short-term panic for a permanent long-term shift.
A panic? Shutting down chemical plants isn't a panic, it's a physical reality.
You are absolutely right that the fertilizer shock is incredibly painful, and the naphtha shortages are causing real industrial delays. But think of the global supply chain less like a fragile glass tower and more like a decentralized computing network.
Okay, I'm following.
When a major server goes down, in this case, the Strait of Hormuz, the data packets, which is global trade, experience massive latency. It hurts. Prices spike. But the architecture of a decentralized network forces it to automatically route around the damage.
Right, but rerouting a digital packet takes a millisecond. Rerouting physical global energy infrastructure takes a decade.
But the capital allocation happens instantly, and it acts as an accelerant. As the old market saying goes, the cure for high prices is high prices.
Meaning?
Meaning, because fossil fuels are so expensive and unreliable right now, the global transition to renewable energy is accelerating at a breakneck pace. The source data we are looking at highlights China's, quote, gigantic, record-breaking surge in solar panel exports.
Well, yes, China is exporting a massive amount of solar, that's true.
We're seeing developing nations across Africa and India importing solar technology at unprecedented levels, precisely to bypass the volatility of the Gulf. So this energy crisis isn't breaking the global system, it's a catalyst.
A catalyst for what, exactly?
It is forcing the global economy to leapfrog its dangerous fossil fuel dependencies and build a much more localized, resilient energy matrix. The system is evolving.
Okay, but you can't separate that economic evolution from the reality of national security. Let's follow your logic here.
Sure.
If the economic reality is forcing nations to radically adapt their energy grids because the old shipping lanes are no longer safe, how is that reshaping global military and diplomatic alliances?
I don't think it fundamentally alters them.
It absolutely does. Because if a nation can no longer rely on the United States Navy to keep the sea lanes open for its basic energy and food inputs, it fundamentally loses faith in the U.S. security umbrella.
I just don't see evidence of nations abandoning that security umbrella.
We're seeing it everywhere. It's not just about energy independence, it's about military autonomy. European leaders are right now openly mulling what mutual defense looks like completely outside the framework of NATO.
That's just contingency planning, though.
Is it? Japan has just ended its post-World War II ban on lethal arms exports to rapidly expand its independent defense capabilities. This is a country whose constitution famously renounced war, fundamentally shifting its posture because it sees the writing on the wall.
That's a shift, yes, but...
And look at diplomacy. Spain's Prime Minister Pedro Sánchez recently made a highly pragmatic trip to Beijing to position Spain as a mediator. Why does that matter?
Because Spain is a NATO member.
Exactly. Because Spain is a core NATO member. And instead of relying entirely on a united Western front dictated by Washington, it is bypassing the U.S. to deal directly with a rising multipolar power.
Okay, I see where you're going with this.
These are not the actions of nations confident in a U.S.-led order. They are actively hedging against it, because the structural guarantees of the past 50 years are failing.
Okay, but you are interpreting an evolution in burden sharing as a rejection of the order itself.
Burden sharing?
Yes. What you just described, Japan stepping up its defense capabilities, Europe taking its own security more seriously, this is exactly what the United States has been begging its allies to do for decades.
Well, sure, Washington has asked for it.
Washington has explicitly asked its partners to stop free riding and take more responsibility for regional stability. When German Defense Minister Boris Pistorius says Germany must do more for Europe's security, that isn't a fracture. That is what a healthy, mature alliance actually looks like.
But they aren't doing it to help Washington. They're doing it because they realize Washington might not be there to help them.
Even if their motivation is self-preservation, the result is a stronger, more capable alliance network that shares fundamental democratic and market values. It's a consolidation of the Western Bloc.
I'm not so sure it's a consolidation.
Look at the evidence of their unity. That 90 billion euro EU loan to Ukraine, that was achieved after Hungary finally lifted its veto. When it truly matters, when the pressure is highest, the established alliances consolidate and act cohesively.
I mean, eventually. Yes.
Let me ask you this. If the U.S.-led order is truly collapsing, why are nations still deeply reliant on U.S. mediation and financial backstops the second a crisis hits?
Are they reliant, though?
Yes. We just saw the U.S. Treasury step in to organize direct financial intervention for Gulf allies who requested support. we are seeing crucial peace talks being organized in Islamabad, precisely to manage the U.S.-Iran crisis, with the U.S. at the center. When the stakes are highest, the world still turns to the established unipolar power.
See, I come at it from a different way. They turn to Washington out of immediate, pragmatic necessity, not out of a long-term strategic commitment to unipolarity. And the peace talks in Islamabad are actually a perfect illustration of this shift.
How so? The U.S. is right there at the table?
Think about the location. Pakistan is stepping in as a mediator precisely because traditional Western-dominated channels, like Geneva or Washington, are now viewed as insufficient or overly biased by the actors involved.
It's just a different venue.
It's more than that. Yes, the U.S. is at the table, but it is no longer the sole architect of the outcome. Furthermore, the source material notes that the Gulf states themselves are deeply worried that these U.S.-Iran talks might cement Tehran's grip on the Strait of Hormuz.
They have concerns, naturally.
They feel entirely excluded from the decision-making processes that directly affect their physical survival. When traditional allies feel marginalized by the hegemon, they start looking for alternatives. And that leads us to look beyond the West.
Right, to the global south.
Exactly. When we expand our lens to the rest of the planet, to Latin America, Africa, and Asia, we see how the global south is responding to this perceived power vacuum.
I agree we need to look at the global south. Absolutely. But I think you're misreading their intentions. From where I sit, these emerging economies are still entirely eager to participate in and benefit from the established globalized economy.
They want economic growth, yes, but they are actively constructing an alternative architecture to achieve it. Look at the recent BRICS consultations.
Okay, BRICS.
Russia and China didn't just issue neutral boilerplate diplomatic statements. They explicitly backed Iran's position regarding the conflict. This is a massive, coordinated diplomatic bloc operating entirely outside of U.S. influence.
It's a statement, but it's not a formal military alliance.
But it goes much deeper than just the Middle East. Across the African continent, states are heavily discussing and operationalizing the concept of multiple sovereignty.
Let's define what we mean by multiple sovereignty in this context, because it can sound like a bit of an academic buzzword.
Right. It's a very tangible strategy, though. Multiple sovereignty is a direct intellectual and political movement by post-colonial nations to decouple from strict Western dependency.
So playing both sides, basically.
Or like playing all sides. In practice, it means an African nation deciding it doesn't have to align exclusively with Washington or Beijing. It can host a Chinese mining operation, contract a Russian security force, and accept an American tech infrastructure project simultaneously.
Playing the great powers against each other for maximum local benefit.
Exactly. We are seeing discussions around a pan-African carbon exchange to control their own resources. In Latin America, we have an international coalition featuring the leaders of Brazil, Mexico, and, oddly enough, Spain.
Right, Spain again.
Openly calling for U.S.-Cuba de-escalation, actively challenging U.S. policy in its own hemisphere. We are even seeing rising U.S.-China tensions over something as simple as a hospital construction project in the Bahamas.
It's a hospital.
But it's about influence. The Global South is not just complaining about the old order, they are actively building alternative partnerships.
I don't disagree that the Global South is asserting its voice. I mean, that's undeniably happening. But having alternative partnerships and a louder voice on the global stage does not mean these nations want to tear down the existing financial and diplomatic architecture.
I'm not saying they're tearing it down. I'm saying they're bypassing it.
Engaging with China on a hospital project in the Bahamas or creating a pan-African carbon exchange, those are perfectly rational, localized economic moves. But they don't negate the primary economic gravity of the planet.
Which you argue is still the West.
Yes. While the Global South is absolutely asserting its sovereignty, which, by the way, the established rules-based international order is theoretically designed to protect, it ultimately still seeks deep integration into Western markets.
But the terms of that integration are shifting. They are no longer accepting whatever terms Washington dictates.
They are negotiating for a better seat at the table, yes. But they are not trying to flip the table over. Look at the source material regarding India. India is the prime example of this dynamic.
Oh, India is a fascinating case right now.
Right? While BRICS might be holding consultations and talking about alternative currencies, the U.S. ambassador in New Delhi is actively pushing for a comprehensive win-win trade deal with India.
True.
India's exports to the United States have increased, and they're formalizing bilateral trade agreements. Major emerging economies are incredibly pragmatic.
Very pragmatic.
They might buy discounted Russian oil in the short term, but they are still prioritizing lucrative Western market access and advanced technology transfers over strict ideological alignment with a fragmented, multipolar bloc. The system is accommodating their rise without shattering its core framework.
Okay, I think you just proved my point, actually.
How so?
The fact that the U.S. ambassador is having to aggressively push for a win-win deal with India shows that the leverage has completely shifted. In a truly unipolar world, the hegemon sets the terms.
It's an alliance. It's a partnership.
Today, India is freely importing Russian oil at a massive discount, successfully navigating U.S. sanctions and maintaining its absolute strategic autonomy, while Washington has to smile and ask for a trade deal. That is the very definition of multipolarity.
I wouldn't go that far.
It is. The United States can no longer dictate terms. It must compete for influence on a transactional, case-by-case basis, just like every other great power.
But they're still competing within the system the U.S. built.
When you combine the physical breakdown of critical supply chains, like the urea and NAFTA we discussed, with these undeniable diplomatic shifts, the picture is incredibly clear. The era where a single superpower could unilaterally guarantee global security and economic stability is behind us.
I hear you.
We're moving into a world of regional blocs, transactional alliances, and true multiple sovereignty.
And I maintain that what you are calling a breakdown is actually a demonstration of profound elasticity.
Elasticity.
Yes, a rigid unipolar system would have shattered when Brent crude hit $100 and the most important energy choke point on Earth was blockaded. Our system didn't shatter.
It's definitely shaking, though.
But the S&P 500 reached record highs because capital is efficient. Supply chains are painfully but successfully rerouting, acting like that decentralized network routing around a down server.
Painfully being the operative word there.
Painful? Yes. But the surge in Chinese solar exports shows how quickly the global economy can innovate its way out of a physical energy trap. And diplomatically, whether it's the EU unifying around a massive financial package for Ukraine, or Japan stepping up its defense capabilities to share the security burden, the core pillars of the international order are reinforcing themselves.
We'll see how long that reinforcement holds.
The system is heavily stressed, absolutely, but it is enduring precisely because it is capable of evolving.
Well, if we step back and look at the totality of what we've unpacked today, my position remains that the fractures we are seeing are structural and permanent. You can print money to bail out a market, but you cannot print the physical chemicals required to grow the world's food or manufacture its goods.
True, the physical bottlenecks are real.
The physical realities of break-in supply chains cannot be waved away by stock market rallies. And when you look at the definitive shift toward multipolar diplomacy, from Japan ending its pacifist export bans, to Europe looking past NATO, to the global South operationalizing multiple sovereignty and backing Iran through BRICS, we are witnessing an irreversible departure from the old world order. The planet is fundamentally reorganizing itself into a decentralized, regionalized reality.
And my position remains that this reorganization is proof of the existing system's durability. While the planet is undoubtedly facing severe, tangible energy and supply chain stress, the incredible resilience of global markets, the rapid technological adaptation driving the renewable energy boom, and the strengthening of core Western alliances prove that the U.S.-led global framework can absorb this crisis. It is an evolution, not an extinction.
I think we can both agree, however, that regardless of whether the system bends or breaks, the Strait of Hormuz blockade and the U.S.-Iran conflict are acting as massive planetary catalysts.
Oh, without a doubt.
They are permanently altering how every single nation on Earth, from the Bahamas to South Korea, approaches its basic energy security, its supply chain resilience, and its national defense. The world before this crisis is simply gone.
Absolutely. There is far more nuance to explore in the source material regarding these planetary shifts, and the true impact of these events will unfold over decades, not days.
Decades, easily.
We will leave it to you, the listener, to form your own conclusion on where this is all heading. But the next time you see headlines about a crisis halfway across the globe, remember that a blocked strait doesn't just stop a ship. It redraws the map of global power. Thank you for joining us.
That's it for today's Artificially Informed.
Thanks for spending your time with us.
Yeah.
Stay sharp, stay curious. See you next time.